Hey y'all, so this video is multiplying and dividing radicals. I'm Christy Fowler and this is Yadkin Early College. So when you're multiplying, which you guys did a good job of that in class today, when you're multiplying, if you have, say, two radicals, the square root of 2 times the square root of 8, you keep the radical sign, okay, or the square root sign. The radical sign is what we call the square root sign. And you simply multiply 2 times 8. And 2 times 8 is 16. So you have the square root of 16, which equals 4. Now another example over here, you'll see we have 4 times the square root of 15 times the square root of 3. Now again, since 4 is the only number right now that's outside the radical sign, we're just going to keep it outside the radical sign. All we're going to do with our multiplication is do 15 times 3. Alright, so that's demonstrated here, 15 times 3. You'll notice I didn't actually do the 15 times 3. There's a reason. It'll save you some time later. What I did next was I took the 15, I broke it up into factors. 3 times 5 gives us 15 times the 3. Alright, then over here I noticed that I have two 3's. Well, 3 times 3 is 9. Okay, or we can think of it as 3 squared. And since we're still dealing with radicals here, the square root of 9, or 3 squared, is 3. So we bring that 3 outside. You do 4 times 3, which gives you 12. And since the 5 is what we had left over underneath the radical sign, it stays under the radical sign. So your solution here is 12 times the square root of 5. Alright, here's another example. In this case we're doing the distributive property because we have a value, 2 square root of 5, sitting outside of parentheses. Inside the parentheses we have the square root of 6 plus 2. So we're going to do your distributive property. So you do 2 square root of 5 times the square root of 6. That's demonstrated here. Alright, and then plus, don't lose the plus sign, 2 square root of 5 times 2. Alright, so your distributive property. So, focusing on the 2 square root of 5 times the square root of 6, multiply our two numbers that are under the radical signs, 5 times 6, which gives us 30. So the 2 is still on the outside. We have 2 times the square root of 30. Now when you look at 30, there's really nothing you can simplify out of that. There are no factors of 30 that are perfect squares. So it's just going to stay the square root of 30. If we go back to the other side, 2 square root of 5 times 2. Well, 2 times 2. Okay, we're going to do that, which gives us the 4. And the square root of 5, since there are no other radical signs here to multiply anything by, we just leave it square root of 5. So you have 4 square root of 5. Alright, so I've given you a couple of practice problems. They do not have solutions on this particular slide. So what I want you to do now is pause the video and work out these two problems. When you've got the solutions, go to the next slide. These problems have been worked out for you. So the solution to those two problems, the first one, you have the square root of 15 n squared times the square root of 10 n to the third. Bring it all, since everything's under the radical sign, just go ahead and rewrite it so that everything's still under the radical sign. You can see I have reorganized and I have put the numerals together and I've put the variables together. Then I've broken it up into factors. So 15 is 3 times 5, 10 is 2 times 5. And then I went ahead and combined my n's. N squared times n to the third is n to the fifth. Down here I rewrote my factors so that I would end up with my two like factors together. I also broke the n to the fifth power back up again. And I broke it up so that n to the fourth was separated from n to the first, because I know that the square root of n to the fourth is going to give me an n squared. Alright, so then also with my 5, since I have two 5's, that's 5 squared. The square root of that is just 5, so I bring that out front. I'm left on the inside with that 3 times 2, which is 6, and the n to the first power, which is n. So my solution is 5n squared, square root of 6n. the solution to number 2. Looks like a whole lot of work. I tried to break everything down for you, so that's why it looks, a little complicated. Some of you may have skipped a few steps. Alright, so again, you're doing the distributive property again. 2 square root of 15 times 3 square root of 3. Also 2 square root of 15 times 3 square root of 5. So you can see as I've worked this out, I've tried to break things down into factors, which is a big thing. Whenever you have double factors underneath your radical sign, that means you take the square root and bring it outside. Alright, and you end up with a solution of 18 square root of 5 plus 30 square root of 3. Okay, so when we start talking about division, remember that division is simply writing something in fraction form. And when we're talking about division of radicals, remember it doesn't always mean that you're going to do long division and break things into parts. Sometimes with division it's simply simplifying fractions. And that's what we're going to be doing here with our radicals. We're going to be simplifying radical fractions, basically. And again, look for something to simplify. Always do that first. Check that first, whether you're talking about radicals, rationals, complex numbers, any of the things where we have done division or fractions or any of that work, always look for something to simplify. And as with complex numbers, never leave a radical in the denominator. We don't want any square root signs in the denominator. So we're going to do several examples here. Here are a few examples at first. Sorry the picture is a little blurry, but look at it hard enough and it'll shape up. Alright, so you start with the square root of 15 divided by 5 square root of 20. Okay, so the square root of 15, remember we're going to break that up into factors again, 3 times 5. And I'm also going to break up the 20 so that it's 4 times 5. Break it apart. Okay, so the square root of 3 times 5 is the same thing as the square root of 3 times the square root of 5. That's where I am over here. Okay, and also the same thing with your 4 and your 5 in the denominator. Now, the whole reason of breaking that down into factors is so that we can simplify. Alright, so down here in this next row, I have gone ahead and simplified the square root of 4, which gives us 2. Alright, so now I'm going to be able to multiply that 5 and that 2 together. And you'll also notice, hopefully, that this square root of 5 occurs up in the numerator and the denominator. So we're going to be able to simplify that. So in this next step here, I did the 5 times 2, which gave us our 10. And in our final step, I went ahead and simplified and took out that square root of 5 over square root of 5. Because square root of 5 over square root of 5 is actually 1, and anytime you multiply something by 1, it's itself, so you're left with the square root of 3 over 10. Alright, so that one, not too bad. Down here in the bottom, excuse me, so I have the square root of 6 over the square root of 27. Again, I broke that up into factors. I have the square root of 2 times the square root of 3 over the square root of 9 times the square root of 3. Now, again, you've got your 3 and your square root of 3 and your square root of 3, which you can cancel out. That gives you 1. And also in your denominator, you have the square root of 9, which gives you 3. So you're left with the square root of 2 over 3. Here are a couple more practice problems. Again, pause your video here, work out the 2 problems. The solutions will be on the next slide. The first problem is the square root of 8 over the square root of 100. Problem 2, 3 square root of 20 over 2 square root of 4. And your solutions, go ahead and simplify. So the square root of 8 is the same thing as the square root of 4 times the square root of 2. And the square root of 100 is 10. Excuse me again. So the square root of 4 is 2, which that's what that says right down here at the bottom. And you're left with 2 times the square root of 2 over 10. Well, 2 over 10, 10 has a factor of 2, so 10 divided by 2 is 5, and you're left with the square root of 2 over 5. Problem number 2, again, breaking up into factors. The numerator, you have 3 square root of 4 times the square root of 5, and 2 square root of 4, well, the square root of 4 again is 2, so you have 2 times 2. Square root of 4 in your numerator is 2, so you have 3 times 2 times square root of 5. In your denominator, you still have 2 times 2. Now I left it as 2 times 2 here because, hopefully you notice, you're going to be able to cancel out this 2 over 2 because 2 over 2 is really 1, and you're left with 3 square root of 5 over 2. Now, in an example like this next one, this is one where you can't just simplify. You're going to have to do a little bit more work in order to get that radical sign out of the denominator. You have 4 over the square root of 5. There's no simplifying here. So, how do you get rid of a square root sign? You square a number. So, what you're really doing here is you're going to multiply your denominator by itself. Okay, and that's going to get rid of the radical sign in your denominator. So the square root of 5 times the square root of 5 will end up giving you the square root of 5 squared, which is what you want. It's going to leave you with 5. And again, though, with your rules and laws of fractions, almost lost the word there, what you do to the bottom, you got to do to the top. So if you multiply your denominator by the square root of 5, you have to multiply the numerator by the square root of 5. So 4 times the square root of 5 is 4 square root of 5. You have the square root of 5 squared, which we have already said is going to give you 5. And you're done. Your radical is out of your denominator. Nothing else can be simplified. That's all you can do. So here's your practice problem. Again, pause the video here, work the problem out, then go to the next slide for your solution. So the solution here, again, since you have a radical in the denominator, you can't simplify anything. You're going to multiply your denominator by the square root of 3 because that's going to get rid of the radical sign. And what you do to the bottom, again, you got to do to the top. So the square root of 5 times the square root of 3 gives you the square root of 15, and the square root of 3 squared gives you 3. Now, sometimes you're going to be given binomial denominators, and you're going to treat these binomial denominators a lot like what we did with complex numbers. If you remember back to when we had problems like 3 plus I, and we had to get rid of those i's in the denominator. Remember we talked about something called the conjugate. Your conjugate, remember, if you have 1 plus x, the conjugate of that is 1 minus x. Because when you do the multiplication of those two numbers, remember it cancels out the middle terms, and you're left with the first numbers being multiplied by each other and the last numbers being multiplied by each other. Alright, so this example over here is going to walk you through that process. So in this example, you're given 3 plus the square root of 5 over 1 minus the square root of 5. Again, we've got to get rid of that radical sign. The only way to do that is to multiply by the conjugate, okay? So since we have 1 minus the square root of 5 in the original problem, you're going to multiply by 1 plus the square root of 5. Now, I went ahead and I did all my foiling. That's what you're doing here. You're foiling, okay? And my numerator, after I foiled, this is where I've done my multiplication, and in my denominator, here's my multiplication for that as well. Okay, you'll notice here the biggie is that the middle terms are going to cancel. They should be opposites of one another, which leaves us with, in your denominator, 1 minus 5, which is what we want, and in our numerator we have 3 plus 4 square root of 5 plus 5. Go ahead and continue to simplify. 3 plus 5 gives you your 8, and 1 minus 5 in your denominator gives you negative 4. Now, we can simplify this a little bit more if we factor out a negative 4 in the numerator. Okay, that's going to give us a negative 4 on top and a negative 4 factor in the denominator. So we're going to be able to cancel those negative 4's out, which will leave us with negative 2 minus the square root of 5. Here's a practice problem. Pause the video, work out the problem, solutions on the next slide. Alright, so here's your solution worked out. So again, we're multiplying by the conjugate of the denominator. Your conjugate of your denominator should be 2 plus the square root of 3. What you do to the bottom, you do to the top. You're going to do your FOIL method of multiplication. Alright, so there's all that multiplication worked out. Simplifying, simplifying, and you get down here where you should have a 1 in your denominator, so you have 13 plus 7 square root of 3 over 1. Since you have a 1 in your denominator, that means you can erase it, get rid of it, whatever, and you're left with 13 plus 7 square root of 3. That's it, y'all. See you later.